This is lesson 3.1, elementary algebra, and this is called paired data and graphing ordered pairs. Hopefully we can get through this in one video because it's a pretty short lesson. First thing we're going to look at are scatter diagrams and line graphs. And one of the things that you're going to do is you cannot get away from graphing. If you have a dread for graphing, you're just going to have to do the best you can, learn it. I will try to make graphing as simple as possible because it will never go away. I mean, it doesn't matter what math you take, there's going to be graphing. And one of the things that you can look at as far as a graph is concerned, when you have an equation, like, for example, 3x plus 2y equals 12. Okay, that's the name of the equation. Think of the graph as a picture of the equation. This is the name, and when you put like my name, Gary Leiter, if you take a picture of me, you're going to get a photograph, a visual of me. Whereas when you're looking at an equation, that's the name, you take a picture of it, and you may get a graph that looks like that. So you're going to get a picture of the equation. That's really all a graph is it's visually being able to look at an equation to make it simpler to figure out. All right, so this one in particular is it's called a histogram or a bar graph because we've got bars, obviously. And I don't know why this keeps going to a dot instead of my cool little arrow. All right, so what we've got is we've got a vertical and a horizontal. Now, usually the horizontal is your time. If you have a choice of time and something else, time usually goes on the bottom. And this is the time in seconds. So we are looking at the speed of a race car. Obviously, as time goes by, it accelerates faster and faster until the end of 6 seconds. It's going 228.1 miles per hour. So at 0 seconds, when it starts from a stop position, it isn't moving. Okay, there's no line. At 1 second, it's going 72. So 1 second, they went up to 72. So see how they just kind of put some numbers here. It doesn't matter if you did 1 to 250 or spread them out so that you're writing fewer numbers. But you kind of go, okay, somewhere between 50 and 100, yeah, that's about 72.7 at 1 second. At 2 seconds, it's 129.9, and as you go through 3, 4, 5, 6 seconds, the speed gets higher and higher. Okay, and that is a bar graph. Now, if you wanted to do this as a scatter diagram, which is at the bottom of 183, you would have put a dot here, 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 and here, instead of making those little rectangles. And then, if you wanted to, then you could connect the dots to get an idea of how fast this car is accelerating. So you notice from here up to about here, it's accelerating pretty quickly. There's quite a bit of a jump. But once you get from here to here, it's kind of slope. It's getting not as steep of a slope here, not as high. So you can just tell by the graph that, okay, it's still accelerating, but not as quickly as it did from here to here. Because like from here to here, between 0 and 1, it went almost 73 mile an hour was gained. And then between 1 and 2 seconds, you've got another 60 mile an hour almost gained. But see, here to here, we're down to 30, and here to here, we're at 30, and then from here to here, we're only at 20 mile an hour difference, and then here we're at like 14. So see how the acceleration slowed down here. So that's one of the nice things about looking at these graphs is you can get a lot of information. So that would be a scatter because you're putting scattered dots here and then connecting them with a line to show a relationship there. All right, so here is another example of a scatter graph here. Get rid of my thing here. There. So you've got the dots here that were graphed, and then you connect the dots and get a little bit more information about what's going on there. All right, so let's get rid of that. And let's look at the rectangular coordinate system. The rectangular coordinate system is that graph that you will use forever and ever, amen, in any of your math classes. So, a couple things to label here. The up and down line is your y-axis. The left to right line is your x-axis. Your origin is where they cross. That's a 0. And then each of these blocks here, there's 4 of them. That's where the word quadrant comes from. Quad means 4. And the first quadrant is right there. Second, third, fourth. It does not go clockwise. It goes counterclockwise and starts in this odd place right here. Okay? So that's just some information on your XY axis is what we call it. You also can call it the Cartesian plane. Some people call it the rectangular coordinate system. It just kind of depends. I call it the XY axis. It's just easier. It comes out of my mouth a lot faster. Now, what you can do with the XY axis is you can graph points on it. So if I were to say I want you to graph a point that lives at 3, 2. The first number is your x coordinate. Your second number is your y. You always start at the origin, and so you start here, and it says x. Well, x is left to right. So that means I go positive 3. Positive is always in a right direction, 3. And then it says, okay, once you get there, turn and go in a positive direction, y. A positive direction is always up. So that point is right there. So when y is positive, you go up. When y is negative, you go down. See the negatives right there? And the same way with the x. When x is positive, you go right. When x is negative, you go left. Okay? So what it asked me to do is just graph that coordinate 3, 2. And it's real easy to do. I just go over 3, up 2. If I had negative 3, 2, I would have again started here, gone over negative 3 and up 2, because the 2 is positive. If I had negative 3, negative 2, I would have again gone over negative 3 but down 2, because down is negative. Okay? And if I gave you 3, negative 2, I would have gone over, get a different color here, I would have gone over 3, come on, 3, and then down 2, and ended up there. So the key thing that you have to look at is, are these negative or positive? Because negative, if the first number is positive, you go to the right from the origin. If it's negative, you go to the left. And then, so you go over 3. And once you get to that place, this thing tells you whether you go up or down. Up is positive, down is negative. And wherever you end up is going to be like 3, 3, negative 2. You ended up there, so you're going to put your point there. And one of the things I ask you to do, when you put a point, tell me what point that is. Because it may ask you to put several points on the graph, and that's labeling that point. So you just next to it write the coordinates for that. And so this is called an ordered pair. Okay, and the first one is the x coordinate. The second one is the y coordinate. Always, always, always. The x will be first and the y will be second, just like in the alphabet. There's never a time where the x will be second. X is always first, y is always second. Okay, so hopefully that'll keep you from being confused with which one is which. Okay, so let's go ahead and practice some of these. We'll go to example 2. Let me get rid of this graph. And I have a handy-dandy graph there for us to look at. And we're going to look at example 2. It says, graph the ordered pairs. All right, what are the ordered pairs? 3, 4. 3, negative 4. Negative 3, 4. and negative 3, negative 4. So it wants us to graph 1, 2, 3, 4. So let's graph the first one. The first one is at 3, 4. 3, 4. So it's right there. And I'll erase my little trails. And then I put 3, 4. Then I do 3, negative 4. So 1, 2, 3, and then negative. So I go the opposite direction, and I end up right there. All right, and again, I'm going to label that. Okay, the next one says negative 3, 4. So negative 3 is my x. Positive 4, it puts me up there. And again, we're going to label it as negative 3, 4. And the last one is going to be negative 3, negative 4, and I'm going to end up there. Negative 3, negative 4. So there's all 4 of my places. And what else does it say here? Identify which quadrant each point lies in. So this is quadrant 1, quadrant 2, quadrant 3. And these are all Roman numerals. Quadrant 4. That's why you learned Roman numerals, so you knew which Super Bowl was playing, and so you could label your quadrants. Other than that, there's really not much purpose in them. Oh, did I say that? Did that come out of my mouth as a math teacher? Okay, let's look at example 3. Graph the ordered pairs. Okay, there's a list of ordered pairs from example 3, so let's go ahead and graph those. First one, negative 1, 3. You end up right there. I'm not going to spend the time to label them right now. 2, 5. Over 2, up 5. And let's see, 0, 0. Notice 0, 0, it means I go over 0, up 0, so that means that I stay right there on the origin. 0, negative 3. That means I go over left or right. How many? 0. Up or down, negative 3. So negative 3 means down. So I didn't go any left or right. All I do is go down 3. So whenever the x is 0, your answer is going to be on the line. Okay, let's look at the next one. 4, 0. So it says my x is 4, so I'm going to go over 4, and then I'm going to go up or down how many? 0. So again, I'm right there on that line. So when my y is 0, I don't go up or down at all. So there are my 5 points that I graphed, and yay, I'm good to go. And if you are stating which quadrant each lies on, I guess the book wants you to do, okay, negative 1, 3, which is right there, is in quadrant 2. 2, 5 is in quadrant 1. 0, 0. What are we going to do with 0, 0? They're on the axes. In fact, the next 3 are all on the axes, so they're not in a quadrant. So you just don't worry about putting them in a quadrant because they're on lines rather than inside the space here. All right, I'm not going to go over any examples from the problem set 3.1. It's pretty much exactly what we did. The only thing that I would suggest that might be a little confusing is if you look at, let's see, number 14. It says graph negative 5, negative 3 halves. So you go over negative 5, 1, 2, 3, 4, 5, and then down 3 halves. Well, remember that's an improper fraction, so when it's an improper fraction, the top number is bigger than the bottom, and you divide. 3 divided by 2 is 1.5. So I know I'm going to go down like 1.5, and you end up guessing a little bit about where that point shows up. But, you know, when you got a fraction, you just go between the two numbers and you're okay. 29 to 44, they're just asking a bunch of questions. Does the graph of 0, 0 lie on the line? Does the graph of 1, negative 2 lie on the line? So it just asks you some questions. It asks you to graph 2 points and draw a line between them and then answer some questions about them. So it shouldn't be too terribly difficult there. And just go to town.